Hey, folks, welcome back to the show. We have, another one of those episodes. This guest today is a repeat guest, and it has been 2 years to the day, pretty much, just about, since I released our first episode together. His name is Dr. Dayan Goodenowe. And if you've not heard of him before, you are going to be so excited that you are here today and learning what he's going to be talking about, because Dr. Dayan Goodenowe is taking neuroprotection, basically brain health, brain healing, for some of the most intractable conditions that we know of. And making some incredible progress and really changing people's lives. So strap on your seatbelts because we're in for an amazing ride. Now, before we jump in, I want to thank you for being here. Well, we just came through Thanksgiving, Black Friday, Cyber Monday. Probably everybody's a little exhausted, catching their breath and getting ready for the next onslaught for the holidays. But I want to thank you guys for being here and for listening to the show, for your amazing comments. I'd love to invite you to leave a review for this show if you get value from it, because that is ultimately how we get found by more people. And anything else that you need from me, head over to natnidham.com. That's my website. You can sign up for my newsletter there. You can also go to Instagram, follow me at Natalie Nidham. Many, many different ways for us to connect. All right, let's talk about this episode just a tiny bit. So I'm welcoming Dr. Goodenowe back to discuss the incredible progress and updates in his pioneering work on plasmalogens. These are tiny phospholipids that are critical to the brain. 25% of your brain is made up of plasmalogens, people. We explore the importance of plasmalogens in neurological development and their role in treating conditions as vast and diverse as ALS, autism, MS, Parkinson's, Alzheimer's, like the whole gamut. Dr. Goodenowe explains how his organization manufactures these crucial molecules and supports a vast network of doctors with advanced technologies. He delves into the broad implications of plasmalogens for longevity as well as cardiac health and overall functionality, and how restoring these molecules can potentially reverse neurodegenerative diseases as well as enhancing overall health. Now, what are plasmalogens? They're essential lipids found in the brain, heart, lungs, and human breast milk. They are crucial for early brain development and preventing neurodegenerative diseases like ALS, MS, and autism. And we discuss the mechanics behind aging and diseases, stressing the importance of mitochondrial function, membrane structure, and the body's ability to repair itself. Needless to say, this episode is chock-a-block full of incredible information. Now, I'm not going to read Dr. Goodenowe's bio because honestly, we'll be here for a lot longer. It's all in the show notes. I would encourage you to read it because he's a pretty impressive dude. But if you decide after listening to this episode that you want to get your hands on some plasmalogens for yourself or for a loved one, just head on over to prodrome.com and make sure you use code NAT25 to save 25% off your order. And let's jump into this episode. Hey, folks, just a quick reminder that all of the information presented in this podcast is for information purposes only. No medical advice, no diagnosing, no treatments suggested here. Before you try anything that you hear about or learn about here, make sure that you check with your medical provider. Welcome back to the show, Dr. Goodenowe. It is a pleasure and an honor to have you back.
Well, thank you, Natalie. It's really a pleasure to be back. It's been a while. It's time for some updates.
I think it's time. Our first episode that we recorded came out on December 6th of 2022. It was episode number 128. So you guys, if you're new to this podcast and haven't caught that one yet, you're definitely, after you listen to this, you're going to want to go back and get some background there. But so much has changed. And not only that, but then we tried to record again last December. Yes. And then I had serious technological challenges, and now we've been chasing each other around for the last 9 months.
Well, we're 18 months younger now.
So. Right. And not only that, it's like so much has happened between now and then. So we just have more to talk about,
Absolutely.
Which is totally exciting. There's so much great news coming out of your camp. You know, I'm always reading the emails and talking to other people, and there's so much going on in your world that I can't wait to get into. But I think before we do that, for the benefit of people who maybe aren't familiar with your work and have no clue what we're going to be talking about here. Let's start with that little nut, which is a big nut, really. This whole area of what's a plasmalogen, why is it important, and your kind of the seminal work that you did in that space that has kind of catapulted you into the world where you're now solving for things like ALS, autism, and MS, which nobody else can do.
Exactly. Well, kind of where it begins, one thing I think for most people to realize is that like we're really a bricks and mortar organization, right? Like we're not just some company or doctor who understood a plasmalogen and got someone to manufacture them for us. And so we have a lot of physical infrastructure. We do our own manufacturing here in a CGMP facility in Temecula, California. Our laboratories are the most advanced in the world. We have 2 7 Tesla ion cyclotrons that we use for comprehensive biochemical analyses, as well as we do ELISA kits, GCMS. Like we do an enantiomeric separation of D and L serine in our blood testing, which is important for people with excitotoxic diseases like ALS and MS. We also have our restorative health center in Canada, which is on a 10-acre facility with its own lake. And we actually people come there for 3 to 4 months to get restored in Alzheimer's, Parkinson's, ALS, multiple sclerosis. So we actually physically do things. And then we have a large network, about 2,500 doctors in our network and practitioners. And we have grand rounds where we actually do this work, right? So it's not about just having an opinion on something. We're actually rolling up our sleeves, figuring it out as we go, and people get this real live interaction with us. And then we can iteratively improve upon what we start with. And so we have 100 and some thousand blood samples in our freezers. We biobank all of our longitudinal studies. We have programs in Japan and the United States and in Canada. And so we bring this large scale science to the everyday world, right? So the doctors in our network have access to technologies that are typically not available anywhere else. And then we're adding our advanced MRIs. I just finished buying 2 3 Tesla MRIs. One is being installed in the Moose Jaw facility in Canada. One is being here in Temecula. So we do all these advanced technologies on the concept of longevity, because understanding the functional, to me, longevity, immortality, if you will, is simply maintaining functionality, right? And fundamentally, I believe we all are born with immortality and we lose it, because basically I think of life and death as a binary thing. Either you're alive or dead. And so as long as you're alive, you're alive.
You're not dead.
You're not dead. So theoretically, you're immortal till tomorrow, right? And so, you really can't, like, the timeline of some sort of, competition as to the number of years that you can put behind your name is kind of a, idiotic thing if you think about it, because it doesn't really mean anything. And then, and so that's kind of where we look at these things. So when you start looking at health and longevity in that context, and then we just deal with it with large information data sets. So the plasmalogen story obviously came originally from the ion cyclotron work, which we continue to do. Like that's like 30 some years now that I've been working on this kind of stuff. And so the plasmalogens are critical on the membrane stuff. So plasmalogens are one of those core molecules that just escaped our attention. It's a critical element in human breast milk, for example. And so that's why one of our big programs is in autism and early childhood development. And so early on in life, the body starts making plasmalogens basically in the 3rd trimester in utero. And babies are basically born somewhat plasmalogen deficient for the first 12 months, which is why human breastfeeding for the first 6 to 12 months is very critical for early childhood brain development, and many, many stories. For example, even prematurely born babies in the preemie, neonatal intensive care units, they don't use formula milk in those children. They use donated breast milk, because they've known over the years that preemies don't survive, or they don't thrive on anything like that. And it's very interesting that these plasmalogens are highly concentrated in human breast milk, but virtually non-existent in cow's milk or in formula. So the human brain has been designed for this. And so plasmalogens make up a huge component of your brain, like 30% of your total lipid volume. We talk about 50% of your heart, your lungs. So when we talk about COVID, we talk about these inflammatory disorders that really affect heart function and lung function. And our restoration of plasmalogens in these individuals have had just dramatic impacts. And same thing with, in autism and other disorders, that if once people become deficient in them and their endogenous system can't catch up, it's a pretty serious thing. Like your brain, we talk about brain development. We have gray matter and white matter. The gray matter is like your synaptic function, and your white matter is the wrapping and the myelination of the brain, which actually allows you to learn, like allows you to isolate one neurological signal from another. You're born with like less than 5% myelin in your brain. You and I are sitting here with 60% of our brain is myelin, right? White matter. But when you're born, you have virtually none. It's like less than 5%. And over the first few years, and that's why autism really hits this first, if a child gets exposed to certain stressors in that first 3 years of life, it can disrupt that myelination, which is basically neurodevelopmental learning. And it affects that ability of the brain to learn. It's not because we learn by receiving stimulation and then being able to isolate a stimulation, whether it's, what's a dog, what's a cat type of thing, right? You have to visually see this thing, then interpret it. And all that information becomes, the brain is a massive wiring diagram, and the precision of these wires allow us to learn. And as we get older, we become more and more mature. And when people talk about the longevity side, where we start aging, so our brains kind of, in a healthy individual, they get their maximum full development of the human brain is typically in our late 40s, early 50s, which is people think that that younger is better, but really in terms of the myelination and our maximum skill set, if you will, and so when we talk about, if most people that get, over 50 will realize if they, our functionality in our 30s to 50s, most people say, if I could maintain that functionality from forever, those are my best years. Like I've learned a lot. I've got my skill set. I've got a lot of things organized in my life. I have more mental stability typically, right? So when we're younger, we're still building all these things. We're still figuring stuff out. We're still kind of getting, but really in that 30 to 50 year range, we're typically in our prime of our performance, if you will, at our job, at our lifestyle and all that stuff. And so most people would like to can maintain that indefinitely, right? That's kind of the window that you want. And it kind of corresponds to when we start losing some of that brain structure and function, is when it's kind of an inverted U shape, where we have this early stage development in the first 3 to 5 years, even 8, this massive myelination, and then it continues to myelinate. So our brains continue to build white matter up until our 40s and 50s. And so we don't actually start losing it and then we start seeing this slow decline that can accelerate. So when we want to restore health, like people talk about aging with regards to a clock, like we're programmed to age. Okay, and I fundamentally disagree with that completely. I believe aging is more of an apathetic entropy type of thing. They don't really care if you live or die. It's not really so they're not being like the human body and our physiology isn't saying, okay, you're done. It's time to kill you. It's like saying, well, if you live for 300, fine. If you live for 60, fine. I don't really care. As long as you got past this window, you're
on your own now.
On your own now, right? And so
so it's up to you to keep up to maintain the ship.
Exactly.
Okay, well that's actually not a bad way to look at it. It sure beats getting kicked off the cliff.
Yeah. And so then the question is it's like any kind of thing, your car, your house, or whatever it is, it's over. Age is really just an association. You have a longer time for shit to happen, fundamentally. Okay, right. And it could be one thing here, one thing there. But really restoring functionality, like there's no reason why a Model T car can't run as well today as it did when it came off the assembly line, if it's put back together again. Now, of course, the human body is fundamentally more complicated than that. The good news too, though, is that it's alive. So your myelin is made by oligodendrocytes in your brain. It's Schwann cells. Like these are living cells that make the stuff. And so what we've been focusing on over the last few years is really understanding the concept that the body's designed to work. It's really a community of cells and systems that are synergistically connected. And if you give those components the materials to do their job, they'll do their job, right? The oligodendrocyte's job is to wrap myelin around axons. That's their job. Like if it can't do the job, then things get damaged along the way, right? Your heart myocytes, they have a job to do. Your lung cells have a job to do. And so fundamentally, the human body is designed in such a way that, and what we've been learning over these years is that it's not really about disease. And I tell this story. I remember when I was a kid, going through school, university, I used to work for the ag companies in the summer times. Do agricultural plots. Like my first degree is actually in agricultural chemistry, synthetic chemistry, and my PhD is in psychiatric medicine. And so I'm a farm boy, right? So I learned all this farm boy stuff. And so, anyways, the point of the story is that they give us all this educational training for driving, like defensive driving courses we were all forced to take. And I remember this one slide set or whatever it was that back then when they didn't probably have videos, but it was a picture of this car. And if you ever driven down the prairies or in the middle of Kansas and it's just wide open country, right? And you see this row of telephone posts, like it's out of the middle of nowhere, right?
Yeah.
And there's a picture of this car rammed right into a telephone post, right in the center of the radiator, right, just in the middle of nowhere, right? Like all there is a post, like in this field, and somehow this car hit this post.
It found the post,
right?
Yeah.
And I'm going, how is that possible? Like if you close your eyes, you couldn't hit this post, right?
Yeah.
And that to me is like what we do with disease, right? We focus on disease, and we get so focused on the disease, we forget about all the space outside of disease. Okay, we forget about, and so that they're teaching us in this course is, look for your exit. Don't look at the accident. Look for how you're going to drive away from the accident, right? How are you going to functionally avoid this situation, right? And the similar thing comes with disease, right? Because we someone gets a disease, Parkinson's, Alzheimer's, whatever it is, right? And there's a biomarker for this, there's a biomarker for that. Like it consumes our attention, right? So everything swirls around the disease, and we forget about the actual reality is you have to be able to think, right? It's the actual functionality of your synapses that are important. The disease is irrelevant fundamentally, because as a functionality perspective, I want my heart to pump, right? And I want my blood vessels to expand and contract. I want my heart rate variability to work. Okay, I want my kidneys to function and clear toxins out of my blood supply. I want my brain neurons to work. And so it's focusing on the functionality eliminates our concept of disease. And so what we're really focusing on is ignoring disease and focusing entirely on function. And we can measure that. Okay, we can measure the deviation from health and so really the issue isn't about disease anymore. It's about identifying deviations from optimal health and just restoring it. And if we do that, we get amazing results.
So so I have a question because the audience is sitting there going, so basically what you're saying, you're ignoring the disease, you're just focusing on what's working. So
restoring it.
Restoring what should be working.
Right.
So for example, let's take an example.
Sure.
Let's take an example because I'm struggling with the concept. I kind of understand what you're saying, but I'm kind of struggling with it a little bit. So let's say, for example, you pick the example, whether it's Alzheimer's, Parkinson's, MS, pick one, because I know you have massive success stories in every one of those areas. So just so that you guys understand, the audience, this man is not sitting here talking theoretical. Right. We're talking about concrete examples of the work that he's been doing and the results that you've been generating in your clinic. So let's take this to a concrete space, whether it's autism, which might be more complex, but let's say Alzheimer's, Parkinson's, because with Alzheimer's, Parkinson's, and ALS, you have people, and MS, you have people who are functioning just fine, and all of a sudden they get this crazy diagnosis and the whole world falls apart.
Sure.
Autism maybe is more complicated.
All of them. This is a very interesting thing. So take a look at an aging, all of these diseases. Let's take a look at Parkinson's, multiple sclerosis, ALS, which is a little less age associated, but it still has an age association curve, and dementia. Now, as they're all associated with age, right? As we get older. So even if you have a genetic mutation that puts you at risk for ALS, for example, you still don't actually get it till you're in your 50s or 60s. Okay, so you can be sitting with this genetic mutation.
So all that time you've been working just fine. Yeah.
Right. Okay, and so what happens then is you get this deviation from health. So in Parkinson's, what happens is a certain cell type in the brain called the dopaminergic neurons that come from the substantia nigra and they innervate like the globa pallidus and the thalamus and so on and so forth, and they control your fine motor skills. Okay, that's a particular functional system that your body uses, and so they lose the ability to control basically they can't stop moving. People think Parkinson's is a deficiency of focused thought. It's actually the body neurologically. I tell people the brain is like a team of wild horses. It's always on, like you're holding it back. And when we want to do something, we release function, right? So when I move my fingers, it's not that I move my fingers, I let my fingers move. Okay, right now I'm holding.
Because you have like this untapped
Right,
potential.
exactly.
And your
My
fingers
fingers
could be
want
moving.
to move. I'm holding them still. Okay.
Yeah.
And what I do is I let them move when I want them to move. And that's why we can move so fast. It's like a pre-compressed spring, right?
Okay.
And so if you had to actually physically say, okay, let's go send this neuron here and here, that would be way too slow, right? And you wouldn't have that high level of precision that we have in our functionality. So Parkinson's, it's a substantial, these dopaminergic neurons, and they have they get there's certain toxins that selectively hit those types of neurons. So it's like a paraquat, or we do this MPTP toxin model, so on. So that particular system can get damaged. But really, the restoration of it, so people have biomarkers. There's alpha-synuclein, there's this and that. There's a whole bunch of tau formation molecules that you can biomarker that show you have Parkinson's. But really, what has to happen is that cell, the dopaminergic neuron, needs to, why people have symptoms is because that cell no longer can perform its function. And how do you restore the function of the dopaminergic cell is we go into, all cells have some core components of it. So there's a mitochondrial component of Parkinson's, right? They have N-acetylcysteine, like they have glutathione deficiencies, oxidative stress. Okay, so restoring the mitochondrial function. And then the inflammation of the brain, which is associated with all of these neurological diseases, not necessarily causative, but definitely associative, like the microglial. Like once this system gets damaged, you get inflammation of the brain and it exacerbates it. ALS is a good example. The entire progression rate in ALS is correlated with the level of microglial inflammation of the brain. Okay, that's just a fact. And so, and same thing with Alzheimer's and Parkinson's, the inflamed or concussion, post-concussion syndrome type of situations, the inflamed brain accelerates that decline phase, which is why, okay, we get all these great athletes that get hit in the head 10 times playing football, and all of a sudden they don't age so well, right? And so what's happened is that inflamed brain has created an accelerated rate of aging, if you will.
Right.
Okay. So anyway, so Parkinson's is this certain neuron system. But it still has a job to do. Okay, its job is to release neurotransmitters, which is dopamine, and so we can restore that functionality with the advanced lipid nutrition of the brain. So, and when the brain gets overwhelmed, it's a stressor. It just so happens that in Parkinson's, the canary in the coal mine that drops dead first is these particular dopaminergic neurons, because they'll have some sort of selective. But restoring that neuron, okay, the actual core components of a dopamine neuron working is the same as the core components of a GABAergic neuron or glutamatergic neuron for ALS, or the acetylcholine neuron for dementia. It has a job to do, okay? And what happens when it gets inflamed, it just so happens that that particular cell system is the first one. So when we restore restorative neurology, is that we use plasmalogens. Okay, two types. One is for the wrapping of the axons, because all neurons have the same job to do, essentially. They just do different things. We need to restore the myelination. We need to reduce the inflammation of the brain, which is the microglial inflammatory. And then we need to restore the synaptic functioning, which is, again, the omega-3 plasmalogens, the Prodrome Neuro that we use. It stimulates the vesicular release of neurotransmitters. And so what happens then is people deviate from health, right? So Parkinson's is a deviation from health that affects the dopaminergic system in the substantia nigra. Alzheimer's is a deviation from health that affects the acetylcholine neurons from the nucleus basalis, right? Innervation of the cortex. ALS is a deviation from health that selectively affects the gigantopyramid neurons, called these pyramidal motor neurons that go from the motor cortex to the spinal cord. So that's a neuron class. And even if you talk about anxiety and depression, which is a GABAergic system, right? So our GABAergic is still a GABA. That's a neuron system that becomes dysfunctional. But
Mm-hmm.
restoring the neurological function of those systems is fundamentally the same. It is, and we're talking about brain function, there's really 3 or 4 core components. One is mitochondrial function. Okay,
Yeah.
all your people will know that, but that's the engine of all your cells, and it's the number one priority in terms of reducing your oxidative stress. All
Mm-hmm.
oxidative stress, all inflammatory mediators come from mitochondrial overload. Multiple sclerosis and autism are 100% fundamentally underlying mitochondrial insufficiency diseases.
Hmm.
But the symptomatic things is cascades down from there. So you want to restore the mitochondrial function, and these are basic vitamins like your B vitamins, like your thiamine, riboflavin. People don't take niacin, the good old fashioned flushing kind. Okay, take some niacin at night. It's one of the most critical, simple markers. N-acetylcysteine, carnitine, CoQ10. So here we talk just before we went on recording is why the pharmaceutical industry really can't do this restorative health. Is I just listed 6 things, and we haven't even gotten halfway through restorative health. Those are just the
Yeah.
core nutrients that your mitochondria need, right? And we have a food supply, and yes, obviously eat properly, but from a pure biochemical engineering perspective, if you think of your body like a vat of beer or wine, and you want to feed it right, okay, it is a recipe, right? And there's multiple ingredients that are required for the mitochondria, and you have to get them in there. And
Mm-hmm.
so that's a big laundry list, and then so the mitochondrial function is one big deal. The other big deal is the methyltransferase system. Many people talk about they'll have a MTHFR mutation or whatnot, so homocysteine system. But
Yeah.
the methyltransferase system is really critical for brain function because it's used to make things. It's used to make creatine for your muscles. It's used to make the phosphatidylcholine in your membranes of your body. And so the methyltransferase system, again, it's this classic methylcobalamin like B12, methylfolate, trimethylglycine like betaine, those type of things. Maintain that. And then a big thing is reducing the load, like creatine and phosphatidylcholine. And then we've worked a lot with the phosphatidylcholine system, especially for getting animal-based phosphatidylcholine. There's a really, really
Mm-hmm.
big difference between plant and animal-based phosphatidylcholine, especially for brain structure. The rest of the body
Right.
can handle the plant-based PC, but the brain is not designed to take. It's just they're structurally different phosphotylcholines, and
Okay.
it's an energetic demand. So mitochondrial function, methyltransferase function, membrane structure and function is what we talked about, the plasmalogens, and that's one of the big missing links. Everything we talk about is something that most people know about, and we have decades and decades and decades of really good research on this stuff. It's not like this is all brand new information. Okay, this
Mm-hmm.
kind of biochemical restoration has been studied ad infinitum. Okay, in this, the issue is how do we practically implement it? And this is why when we did the
Right.
biochemical reset with you guys last years, it's kind of fun to do because you can actually do this. It's really, biochemical engineering and restoration. And so
Yeah.
the membrane structure and function, getting your cholesterol levels up. This obsession with low cholesterol is killing people. Like people need
Yeah.
their total cholesterols need to be in the mid 200s. Like this, getting people's cholesterol under 200 is ridiculous. So cholesterol, phosphatidylcholine, and the big one is these plasmalogens, and that seems to be one of those components that really. And I published this in the book, the Breaking Alzheimer's book, for example. Right? It's a 30-year differential in lifespan based upon your plasmalogen levels in your blood. Right?
Yeah.
Like your 5-year survival, the 5-year survival of a 65-year-old with low plasmalogens is the same as the 5-year survival of a 95-year-old with high plasmalogens.
I remember that from the book.
It's the most
It's
scary
such a
graph
crazy stat.
I've
Yeah.
ever produced, and that's not a small study. That's 1,200 individuals in Chicago, okay, tracked over like 17 years. Like it's a very, very robust data set. So anyways, so the membrane structure and function, but we need to get that in the brain, right? Your brain absorbs fat in a certain way, and this is why I've been able to show reversing brain aging, like in my own brain, like 15 years in a year, like you can do this. Your brain, and then Lisa, who has MS, like she was legally blind in her right eye for 30 years, and she can now she can read 5 lines. So that's 30 years of blindness, and she can regrow vision after 30 years of blindness. And you can map it on the MRI. You can actually see the connectivity happening, right? So
That's
it shows you
unbelievable.
how powerful our physiology is. Like if you give the cells the materials to do their job, they'll do the job, right? And so we just need to be strategic and we're just plugging these things in and then letting the body do what it wants to do. Like it's fundamentally been being prevented from doing what it needs to do. So the membrane structure and function, peroxisomal function is a big deal with aging. Peroxisomes, people don't really hear about them. It's kind of the second cousin of your mitochondria, but it's critical. It's your anabolic. Your mitochondria are basically your catabolic. So catabolic means breaks down, anabolic means builds up. So your mitochondria are designed fundamentally just to have hydrocarbons come in, carbon dioxide and water come out. Okay, that's its job. Its job is to create energy, ATP fundamentally.
Yeah.
And so it doesn't really make anything. If your mitochondria are making things, then you have cancer. Okay, so you don't want your mitochondria is not supposed to be an anabolic system. It's supposed to be fundamentally.
It's just making energy.
It's a clean burning. It's a little nuclear reactor that's in your cells, or multiple in your cells. Your peroxisomes are your anabolic system. That's what builds your muscles and builds your cholesterol, builds your hormones, builds your plasmalogens, and that's what we do in the fasting state. Like that's why this intermittent, like time-restricted eating, is critical for people. Resistance training, moderate resistance training as we get older is so critical to maintain your muscle mass. And it comes down to this concept: the human body is designed to work. It's designed to work. Okay, we don't need to play God. We don't need to make it something it is not. It actually functions extremely well. Okay. For basically 60 years of your life, you pretty well have to step in front of a bus to die. Okay, like really, like it's unbelievable. Like we take milkshakes and hamburgers, and our body will grow skin and hair and bone and heart muscle from that stuff. Like that's what kind of bioreactor we have. Like think about that.
Yeah,
like that,
it's unbelievable.
Like that's what it's building. It takes all this shit that we eat and it builds stuff with it, right? Amazing. It's you know, and we're so negligent of it, right? We just okay, it's. You know, and we don't realize we can help it. Like we can actually, if you know, and we have the strategic information to provide these core components of it. And then we talk about, and so those are the core components. The peroxisome is really important because it maintains your low triglyceride levels. It's important for your maintaining HDL levels. It's what gives us our, you know, that's why exercise and fasting is what keeps. It stimulates peroxisomal function, which is what keeps your triglycerides nice and low where it's supposed to be. So the thing is, we know all of this, right? And
okay, I have a question.
Absolutely.
When you mention fasting and exercise, are you talking about them concurrently, or are you talking about two separate things? Are you saying separately? Okay, good. That's what because I know that when you read my report, you're like, you need to stop fasting.
Well, the females are really a big deal on that.
You need to cut that out.
So that's the other thing, a lot of the biomarkers. So we do all these advanced blood testing, right? And we want to take advantage of the decades and decades and the thousands and thousands of studies that have been done on all these. Like if you take uric acid or cholesterol or fasting triglycerides, these have been studied extensively in so many different types of circumstances. And so we know what normal is. We know what healthy is, right? And so sometimes we get obsessed because the blood tests have been designed to look for negatives, right? So the creatinine is super high, right? So the creatinine test is fundamentally used for kidney clearance, like if you have kidney failure, right? And so they don't really worry about the low one. We do now because for sarcopenia. So people think of high level, lower is good, but too low is not good either. The same thing happens with homocysteine. So homocysteine means, let's get my homocysteine down low. Well, no, you should be there's a happy space, right? There's 8 to 10.
Well, it's like what you were saying about cholesterol, right? You can't be shooting for the bottom of the barrel with cholesterol. You're just going to get into trouble.
Exactly right. And so I think from a fasting perspective, what's important is that we want to make sure we don't get malnourished. Okay. And so you want to stimulate the fasting of your body. Like, so I tell people the only reason we eat is to store fat. That's it. Like it's your gas tank. Okay. When you're eating, you're at the gas station pumping up with gas. Okay. And then it's taking all the food that you're eating and it's storing it in your adipose tissue, which is distributed all across your body, right? And then that's your skin of energy. And after your gut has digested and distributed it to your fat cells, then that's what you run on. Your body runs on your subcutaneous fat release in your fasting state, right? And that's why you kind of want to have this, in your body is designed to have these cycles up and down. Like you want to have a fed state, you want to have a fasting state. So this really, really super strict keto, I'm not a big fan of that. I think the time restricted, like you want to have, I'm a kind of a carnivore-ish guy. Like I think you want to have mostly good quality meat, good quality fat in your diet, and a little bit of fiber in your process. But you want to be fed. You want your body to get that stimulated insulin, glucose process, and then it should go away, and then you should be in the fasting state for most of your period. But people that do this time restricted, like I like the time restricted eating process because I feel better doing that. People should listen to themselves. But a lot of people with certain diseases in the elderly and in ALS and females particularly, like you need to make sure that your time restricted eating, the window is not too long, and make sure you have a fatty protein snack at night or in the morning, because you don't want to be malnourished. Like, because when you're malnourished, you're biochemically creating a Sophie's choice. Okay, your body's basically got to say, okay, which, what am I going to do? Am I going to make estrogen or am I going to make cholesterol? Like it has to make choices now. Like it can't do both, right? And for women, it's important. Like you can mess up your cycles. You can stop your cycles just by malnourishing. Athletic women they'll get all messed up, right? And the body will say, whoa, I'm in this starvation state. And so I'm going to preserve energy for core physiological functions, where the extra physiological functions, I'm going to say, let's stop that for now. And that's where vitality,
not necessary.
Right. And that's what vitality is all about. Vitality is about having excess. Vitality is about having metabolic bling, basically. It's like, hey, I got extra for this. This is great.
Well, it's about, the only thing is, I think I would define it maybe more as resilience, because excess, now the person who's walking around with 100 extra pounds is going, I got this covered. I got a buffet.
Yes.
Right?
Well, I'm not going
so,
there.
it's finding that, and it's a lot of what you're saying is finding the sweet spot, having enough reserve. And we see this in elderly people who are very, very frail.
Yes.
So they're very thin. They don't have any fat reserves. They literally have no reserves. And in that situation, when they hit a roadblock, whether they get sick or something happens, there's not enough reserve for the body to tap into to get them through the crisis. And that's when things really start to go sideways.
Exactly.
And you talk about that. You were talking about that a lot to us when you were reading our test results, and you were talking about plasmalogen reserves.
Correct. And it's one of
and people will deplete them. Yeah.
And when we want to push the envelope the other way, then we get these kids and the diseases on pretty high doses. Like your body likes plasmalogens. Okay.
Well, plasmalogens is different than extra corn chips.
Yeah, absolutely.
It's a different,
and it stimulates neurogenesis, right? So like the omega-3 plasmalogens, they actually stimulate a very specific peptide in the brain called secretory APP alpha, and that's actually one of the critical peptide signals for the growth of neurons and the neurite growth that happens. And so for our ALS and MS patients, when we're actually regrowing their neurons, and you can track that regrowth, like the high doses of the omega-3s are important, because we're not just maintaining anymore, we're trying to reverse, right?
Well, exactly. You're now moving it to therapeutic. But when you say omega-3, are these specific omega-3s? These are not just the omega-3s that you get from taking fish oil, or are they?
No. Omega-3 is the fatty acid part.
Right.
And the only omega-3 that matters is DHA. Okay. People talk about EPA and this and that, but they don't really understand what that means. Your body doesn't use EPA. EPA is a metabolic byproduct of DHA, and it's an important biomarker. So your DHA to EPA ratios can indicate your peroxisomal function. So there is science behind some of that, but actually in your membranes, it's the DHA that's important. That's what's in your cell membranes. And so, so when I talk about omega-3 plasmalogens, it's DHA that is covalently attached to the plasmalogen backbone. So it's the plasmalogen backbone. So
instead of a glycerol backbone, right? Correct. Because your essential fatty acids are on a glycerol backbone. What you were talking about, the plasmalogen precursor, is on a different backbone.
Right, that delivers it to your phospholipid pool. So, so when you eat a fat, like you eat olive oil or whatever, right? That's an oil, and it's the same as and that's a triglyceride. So that's what you measure in your blood supply. And triglycerides are fundamentally a food supply. Okay, they're not triglycerides are not metabolic intermediates of anything. Triglycerides are the end product. Triglycerides is what your liver makes and your body makes to store. Okay, triglycerides are designed to be shipped to your adipose tissue. Okay, that's where it goes. When you're in the fasting state, you don't actually release triglycerides. You release free fatty acids. Okay.
Right.
So after a meal, my triglycerides in my blood will be very high because my liver and everything is saying, hey, you got lots of energy. I am packing fat into my cells, right? And that's the
Yeah.
triglycerides. I'm sending it all to my adipose tissue. Then after a period of time, when you hit the fasting state, your triglycerides go down. And then what's being released from your fat cells is free fatty acids. Okay. And those get transported on different protein particles called the albumin in your blood. And so that's what the food supply is in your fasting state, is these free fatty acids. So the point of the monitor is when you're taking regular fish oil or algae oil or olive oil, okay, that's a caloric source. That's not a metabolic intermediate to
Right. It's an energy source.
correct. And your body
Yeah. It's not a building block
at all. Exactly. When you take the plasmalogen precursors like prodrome, neuron, prodrome, glia, those are phospholipid precursors. Those are not food supplies. Okay, those go into the cells of the body, and the body takes that molecule and it converts it into the final plasmalogen phospholipid. And since it goes into your cells, it actually donates get technical here, the SN2 position. It donates it to other phospholipids. So it actually, because since it's part of your so your membranes, the membranes of your body are not triglycerides. Your membranes of your body are phospholipids. Phosphatidylcholine, phosphatidylethanolamines, sphingomyelins, phosphatidylserine, phosphatidylinositols, phosphatide, every time you hear
phosphate.
exactly, right? They're phospholipids. And because phospholipids create this bilayer, right? It creates these biological walls. And so that's what was missing with the plasmalogen story over the last 50 years. So it's not like I invented plasmalogens as a new molecule. Like they were discovered back in 1919, and our understanding of their critical component for human physiology happened in the 70s when these leukodystrophies like Zellweger syndrome and then RCTP that we talked about, the rare disease program that I have with kids, leukodystrophies, these diseases have a plasmalogen deficiency and they're high mortality. So if you're born with a genetic mutation that blocks plasmalogen manufacturing, you basically die. Okay, and depending on the severity of your plasmalogen deficiency determines how long you live. Like if it's really, really bad, they'll live for a year or two. And if they have some residual plasmalogens, they can live into their teens basically. So we know absolutely critically important. So you'd think we've known this since the 70s. Okay, I'm not the first scientist in the world to look at something and say, oh, well, let's just why can't we just restore plasmalogens? And so there were some old molecules that people tried, like chimal alcohol and battle alcohols. These are plasmalogen ether lipids. And they just didn't work. Massive doses were required. They tried them in many different ways. And so my contribution to the field was, in around 2006, I was researching this in more detail and saying, I got to figure out how to strategically deliver specific plasmalogens. How do I deliver an omega-9 plasmalogen to the oligodendrocyte so the oligodendrocyte can make myelin? So the myelin has a different type of plasmalogen. Whereas how do I deliver an omega-3 for the synaptic function, so vesicular release, or for reverse cholesterol transport, for atherosclerosis and so on and so forth? Those take an omega-3 plasmalogen. And so you need to manufacture the precursor in such a way that it's deliverable. And that's what my contribution is, that these plasmalogen precursors that I've invented and designed and manufacture, they actually enter the blood, they enter the brain, enter the cells of your body, and they allow the cells to actually restore those plasmalogen levels. And that's why we have these dramatic effects in these diseases, because it's a delivery system that actually gets it where it needs to go. And then when you use that in combination of all the other things that we talked about, right? Good nutrition, animal-based phosphatidylcholine, the mitochondrial support, that stuff. Then all of a sudden your body just kind of wakes up and it says, wow, okay, I'm ready to rock and roll. And even like we do a lot of work in SIRS and COVID, inflammatory disease. And that's where the omega-9 comes in. That's like for autism. And it's quite shocking to see. Like there's the stories, like it really, even when I hear these stories and I see these stories, people send me videos of children that are just banging their heads, they're violent, they're basically ready to kill their parents, and then they normalize. They become affectionate. And it's because their brain is inflamed and they're just
On fire.
The inflamed brain is driving them nuts. It's
Yeah.
driving them crazy
Yeah.
on the inside. And they can't think. They can't think because they're in this massive stress mode. And this can happen to, you don't have to have autism for this to happen, right? You get people with COVID, they're high functioning individuals, for example, and all of a sudden they just can't think, right? I can't put a thought together. I can't think far in the future. A high functioning person with, cognitive skills can't think of numbers anymore. And then you can feel it. I just can't think. And inflammation is blocking that. And so when we start, and that's where the glia, the omega-9 is so powerful. It's really it's quite magical for heart function and lung function. And in an inflammatory perspective, people just go, wow, okay, I can feel.
So so you're not just talking brain here, because you've mentioned this a few times now. You've talked about heart, brain, lung, heart, brain, lung, heart, brain, lung. So these are the major organs that seem to be affected. So we talk about the brain so much because we talk about ALS and Parkinson's and Alzheimer's, but there's all these other conditions like the post-COVID syndromes, the SIRS, which is now it's going to affect the brain, but it's also going to affect these other major organs that are struggling. And plasmalogens are going to be just as important for those cells as they are for the brain. Yeah,
especially for cardiac function. It's really like people with the myocarditis, and like one of the first things that happened with Thatcher was a little boy with the RCDP, right? The rare rhizomelic chondrodysplasia punctata. One of the first things that really happened to him is he going in for his routine echocardiogram. So these children with these plasmalogen deficiencies, they normally die of heart failure or lung failure, right? Respiratory disease. And so they monitor these children very carefully. And so he was going for his routine echocardiogram because he had heart failure, right? Which is common in these children. And so after he started taking plasmalogens, he goes in for a routine checkup on his heart. And then the person says his heart's normal. Like his heart completely went to normal functionality. So he has his decreased heart functionality restored to normality. And we see this with people with low oxygenation levels. They bounce right back very quickly. And so for ALS, for example, the biggest issue with ALS, like most people when they have ALS, regardless of whether it's a limb or bulbar, usually it's the biggest fear as they get to a certain level of progression is their breathing and their voice, right? And ultimately people with ALS die of respiratory failure. Like they basically asphyxiate. And so what we notice very quickly for most of them when they start taking the plasmalogens is that their breathing normalizes and their voices come back. That's one of the first symptoms that we see. And that allows them to kind of take a breath, literally a breath.
Take a breath, literally.
Mentally start, planning ahead a little bit better. And then we can start working because restoring the muscle atrophy of the arms and legs takes longer. And it becomes more of a sports injury situation at some point versus the disease, because the disease has caused the damage, but restoring that functionality, restoring physical muscle mass, that just takes time. That's just a process.
So it's overcoming sarcopenia, basically.
Yeah, it's a muscle wasting.
Muscle wasting disease. Isn't it called a muscle wasting disease to some degree?
It's particularly nasty because ALS is what we call an active neurological disease, not a passive, like dementia, Parkinson's. The disease is neurodegenerative, but the process of the neurodegeneration is not propagating. Whereas in ALS, the disease itself is active, and which is why once it gets triggered, it has this very, very precise time window. Basically, 3 years is the average lifespan. 5 years, 80% of the people are dead, right? And so, it doesn't matter when you get it when you're 40, when you get it when you're 60. Like as soon as it starts, it follows this highly reproducible window, okay, which is such a nasty thing. It's because once the motor neurons once the motor neuron death cascade has been triggered, when that neuron is trying to save itself, it starts spitting out by our own natural exosomes. It starts spitting out this misfolded superoxide dismutase, which is toxic. So the disease itself creates toxic mediators, which accelerate the disease. So that's why
Right.
it's nasty.
It's like a spreading disease. It's
Correct.
like a contamination, essentially.
Right. So it's an active neurodegeneration, whereas Alzheimer's
And so,
is more of a passive one.
right. And so do you have a sense with ALS, you mentioned triggers, right? You mentioned earlier that you could be, I mean, and I think with ALS, what I'm starting to really kind of understand by talking to different people is that it's a spectrum. Like so many of these things, it's a spectrum. It's not a one thing. And so you could have an ALS that was genetically, that a person might be genetically predisposed to, which doesn't mean they're necessarily going to get it. And then I would imagine you have people who who develop ALS or ALS symptoms that may not have had that genetic variation. And are you getting to a point, or is science getting to a point of understanding what those triggers might be that are flipping the switch, either like in both cases?
Yeah, but unfortunately, it becomes more of a academic exercise of, how many angels fit on the head of a pin type concept. Okay,
Like, who cares?
Exactly. It is one of those things where there's many pathways to get to ALS, but once ALS is triggered, and still most of it is really sporadic. It's chasing your tail, right? It could be, some person could be mold, some person could be COVID, some person could be metal toxicity, some could have, and it could be both. You could have an underlying genetic susceptibility, which is then triggered by some sort of
by the mold or whatever. Yeah,
exactly. So, but no matter where it gets triggered, once it's triggered, fundamentally all ALS is fundamentally the same, regardless.
Right.
It's an excitotoxic disease. It's a disease where glutamate is just hammering the motor neurons, and the control function, which is this D-serine, is disrupted, and so it just is turned on, and that creates this very reproducible cascade. You get mitochondrial overload. The mitochondrial overload causes excessive glutamate or superoxide demand of the superoxide dismutase. That protein gets overwhelmed, becomes misfolded. It starts spitting itself out. The protective cells, which is called the astrocytes, which are basically these big motor neurons. These are big motor neurons. Like they're like 80 times bigger than a regular neuron. They're huge. And because they're sending an axon from your brain all the way down to your spinal cord, and then your peripheral neurons will go from your spinal cord all the way to your toes. These are very, very long, and so they have a cell body and a metabolic capacity to sustain that level of signal. Like it's got the strongest signal virtually of any neuron in the human body, and so it has a support structure. I call them like the NASCAR of neurons. So it's going to it consumes a lot of fuel, but it also has a big radiator to keep it cool. And the radiator basically is the astrocyte. So it's a support structure. So what happens is when the neuron starts dying, it starts spitting out these toxic mediators, and then they affect the support structure, which is the astrocyte. And so the astrocyte starts to fail. And when the astrocyte fails, the astrocyte doesn't just support the motor neuron, it actually supports the oligodendrocyte wrapping as well. Okay, so when the astrocyte starts to fail, it no longer protects the neuron, and it no longer supports the oligodendrocyte. And so the oligodendrocyte no longer can maintain the myelination wrapping of the axon, which is the white matter component of it. When that fails, then you get oxidative stress. Okay, you get inflammation, and the microglial activation comes on board. And that is what causes the ultimate cascade of ALS, is the microglial inflammation. So we have to reverse that. First of all, we have to restore the myelination on the axon of the oligodendrocytes, reduce the microglial inflammation, restore the mitochondrial function, and once that's in place, then we have to start then all those neurons that most of them haven't died.
They have to rebuild.
Yeah, and it's like they have these very large dendritic paths, and so these little, like if you look at in brain scans, they get these little nodules, if you will. Okay, and the tree fingers come in. So once we stop the death cascade, then those things have to grow back out again, and that's the next phase. And that's when the people start walking and talking and things like that.
And so when you do, okay, so then obviously, so now and this is multi-phase. I just want people to understand, we're not just popping a few plasmalogen precursor pills and making it go away.
Correct.
But once you've taken care of the mitochondria, you've taken care of the peroxisomes, you've taken care of the methyltransferase, like all the things, and now we're bringing the plasmalogen precursors back in. Have we fixed the ship, or are we basically in a world where we're replenishing those systems now in perpetuity to both reverse and restore function? Like, I guess my question is, without using the C word, is there a point in time where that patient is able to say, okay, I can take my foot off the gas. I don't have to keep pounding all this stuff all the time? Or once this process is triggered, it's always going to be there. And you're always, the good news is you're now at a point where you're starting to see that it's possible to slow it down, stop it, and reverse it.
Correct.
But,
so the answer is that, well, obviously you want to maintain the biochemical restoration indefinitely, because you've got to
because it's always going to keep, it'll always revert back to degradation, right?
Even you and me, right? I still need biochemical support. It's not possible in our dietary food supply to maintain our biochemical integrity. So it doesn't really matter. So the issue is redundant in a sense, because once you restore biochemical normality, you want to maintain that restoration. And so,
I wonder with those people though, because there's such an aggressive degradation, like there's such an attack on it to begin with, like you and me, we can take our supplements and, we might miss our supplements 1 week or 2 weeks and then go back. I mean, you might not, but I might, and I'm not going to be any worse for wear. But if someone is one of these ALS patients, I'm guessing they have a little less wiggle room on.
Well, not really. So as soon as the glutaminergic toxicity is handled, and you're really not, and again, it's not a neutralization, it's not a detox in a sense. Mm-hmm. It's basically just giving the motor neurons the ability to survive with those glutamate stressors. Okay. It's just and so it has an extra stress load, but you have now just beefed it up so it's comfortable carrying that load. And so at that point in time, they really don't have ALS anymore. Okay, because it's not really ALS. To have ALS, you can have a risk for ALS. Say you have a genetic, no one would say if you have a genetic mutation that gives you a familial ALS, no one's going to say you have ALS until you actually have ALS.
Until you have ALS.
Right,
yes.
Right. And so, and when having ALS means that you have motor neuron degeneration, and means that motor neuron degeneration is spreading because it is active. As soon as that stops, you actually don't have ALS anymore. What you have is you have a neuromuscular injury now. Okay, because so now you're stuck with the injury that you have sustained. It's like I've been in a car accident and I'm no longer in the car. The car accident's gone. Okay. Yeah. So I'm not I'm not getting hit by a car every single freaking day, but I still got a broken leg. And so I got to recover from the damage of the car accident. And so that's kind of where, so whenever you see someone getting better from ALS, okay, the restoration, that's not that's a repair. That's not ALS anymore. That's like a sports injury restoration part, because the ALS is no longer there, because by definition, you have to have this toxic propagation. Otherwise, it's non-existent. And so it's kind of it's same thing with dementia, right? Dementia is so a person may not have active ALS anymore, but they'll still have atrophy, right? They'll still have muscle weight.
Yeah, no, they've got a lot of ground to make up.
But if they're not progressively declining, then they don't have muscle wasting either. They just have muscle damage. Okay, muscle wasting means that you have progressive loss of muscle. Right. But if you have a low level of muscle and you stay constant, it's like, okay, I don't have muscle wasting anymore. I just have bad muscle tone. I have no muscles, right? So those are two very different questions. Same thing with
now you're in the world of actually thinking, okay, how do we re-engage? How do we rebuild that muscle? How do we bring it back?
And then we can get some more fancy stuff at that point in time. So now we can get some fun stuff. We can get into some peptides. We can get some exosomes with ultrasonic targeting of exosomes to certain regions. So now we can stimulate the regrowth phase like we could do in any type of disease situation. So now we can get, And then if you have the biochemical restoration in place, the body is able to actually deliver on those signals. Like if you're biochemically healthy, and I give you a really good exercise routine, you can become an Olympic athlete because your body is able to do that, right? Okay.
Yeah.
But if you're some malnourished person from sub-Saharan Africa, no amount of training is going to make you perform because you're biochemically not able to sustain what's being asked of you. And so and that's where some of these fancy technologies don't always work, even though they're scientifically logical and valid, but the body has to be able to take advantage of what you're asking it to do. And so if you're creating a signaling system, if it's an exosome or a certain peptide, that there's no mass to that, right? Like, it's an injection, right? It's like there's not
you need the materials.
Mass. Like your body has to say, okay, the peptide may be turning on a switch, okay, but it's not doing the work. Like your body's physiology has to do the work that the peptide is asking you to do. And so I sometimes think in certain circumstances you can go backwards in these situations where you're asking for something that the body can't perform. And this happens in ALS a lot, actually. People over-exercise a lot. They think, and it happens in a lot of athletic A-type personalities, think, well, if I just work out more, I can build more muscle. But it's the opposite, because they're putting more stress on a situation, on a physiological system that is already undercapacitated. So they'll actually
well, it's almost like those micro tears from the workout, you can't repair them. And so whereas a healthy person, the micro tear is an opportunity to build. The person who has no wiggle room, it's just a micro tear.
Exactly.
Then you get another one and another one.
Which is why we've been using the Katsu bands as a really exciting technology, because you can actually stimulate that exercise vascularization without the muscle tears. And so, especially with people with late stage MS or with ALS, they're really quite interesting. So so that's kind of, so I think it's really, so for us, like we're doing this in large scale, like we're starting a very large community trial in Canada where we'll be monitoring MRI, reversing aging in individuals or restoring function, depending on how you want to word it. And
so your center, is it in Manitoba?
It's in Saskatchewan.
Sorry, I knew it was one of those provinces. So
the thriving metropolis of Moose Jaw. You can't make this
Moose Jaw, but I've heard of Moose Jaw. Like it's not. But so your center in Moose Jaw is addressing aging, or is it addressing neurodegenerative ALS? Like what's because I've sent you a couple of people, like people who've told me they have these crazy conditions. I'm like, you need to talk to this guy. Put your life on hold. Pack up your toys, go down there for 3 months, and they'll fix you up.
Right.
I don't know if any of them step through the door, but that's not the point. But is that in Moose Jaw or is that a different place? And in Moose Jaw, are you taking care of longevity specifically?
Yeah, two separate things. So the Restorative Health Center in Moose Jaw, we take people from all around the world to do these worst of the worst to restore them. Okay. The Moose Jaw Vitality Project is a community program. Okay. It's also run out of Moose Jaw, but it's a separate program. Okay, that's where we're looking at. We're going to be working with the entire community of a representative population. So the first program is in autism, and then the aging restore. We'll use the demographics of the surrounding regions, and then we'll start looking at the physiological MRI, functional MRI, structural MRI, heart function. All these basic functionalities. And can we restore healthy functioning in the elderly. So
basically you're going to turn Moose Jaw into like a cobalt blue zone.
Yes, we're going to turn into the Truman.
That's cool.
It's going to be a Truman Show. It's going to be like a fishbowl for us to look at.
A whole new blue zone. Yeah. Okay, well, this is so fascinating. So for people who are listening and who are like, okay, I need some of that juice. Right. And I mean, look, at the end of the day, you've made it very clear that these are not one trick monkeys. But at the same time, if let's say you're someone who feels like you're taking care of the foundation, you're nutritionally taking care of the boat, but you're missing this one piece of plasmalogens, is there a use case scenario for a longevity enthusiast to say, okay, can I can I just use this stuff for, is it a couple of months
Oh yeah,
or
it's great
3 months
stuff.
a year?
So
Should I be, because they're an investment. Like,
yeah,
let's be clear. These are not
they're not
cheap
cheap.
things
Yeah.
to make. So,
But so the two things. So Prodrome.com, okay, the supplements are available to anyone, right? And then drgoodenowe.com is where we have all the education and research studies and a huge amount of information there. But for all of us who just want to play around and hack around a little bit, the omega-9 plasmalogen for calming your brain and sleeping in the rebuilding phase is really quite amazing for sleep
that's the
improvement.
glia.
The glia. To take some of that
Yeah.
at night time, it's amazing stuff. Now, when you're a sports enthusiast and you really want to improve neuromuscular function, the Prodrome Neuro is really quite amazing. Like your recovery times, your muscle growth and development. And if you take that with other things like with say ketone esters and the plasmalogen simultaneously, they're pretty powerful combination. You'll notice differences. Like if you take a dose of this stuff, your eye, like you'll notice lights get brighter, restoration of vision. Like my vision is back to when I was 17. Okay, even better. And so I can't even wear my progressives anymore. So my vision is fully restored, as well as it ever has been, if you will.
Restored from what? From myopia?
Yeah, like so I'm naturally nearsighted, right? And so
you can't see from far.
Right. So even when I was in university, I would always sit near the front because I'd have a hard time reading the board, even playing hockey and stuff like that. And so, but I noticed, I'm 55 now, and so I noticed, in my early 50s, I was starting to, have a hard time reading. I get headaches, work on the computer all day long, and that's all gone. That's most people notice, and their night vision. People really notice their night vision comes back, and their peripheral visions. So that kind of stuff you'll notice. But I notice I've always been kind of an athlete, on and off, like get on the wagon, off the wagon. But
yeah,
I'm stronger now than I was in my 20s and 30s. My recovery times are better. My pain is gone. That type of stuff.
That's amazing.
It's pretty neat. So you'll notice it pretty quickly. It wakes you up.
And so how much does a person need to take? Let's say somebody's going to go in for a workout of some kind and they've got their ketone esters and they've got their bottle of their neuro. Yeah. What are they going to, so how much of the neuro should they take?
If you're
like
going to go, capsules? I always tell people, like, buy a few bottles, and you want to go through a bottle of each a week, because if you really want to try this stuff out, take the time to invest enough in it. But the optimal dose, so depending upon what you're at, like if you're in an active inflammatory state, if you're in SIRS, like you want to take low doses of the omega-9 at first, like you go slowly. But if you're just like a healthy person and you say, hey, I'm kind of, this sounds like fun, I want to see how it affects my workout, my eyes and whatnot. And same thing here, like all of my, like the smile lines are gone in my face. And so those things, take a bottle of each a week for a month, right?
Okay.
And you'll notice some pretty big changes. You feel sharper, your memory, your things, it really does make an impact. And then you can kind of.
Okay. And as we said, they're a bit of an investment, but we have a code for you to help you out. It's NAT25. Yeah. So, you can use the code. It'll help you out. But definitely, I think it's an interesting thing, because if you do it for a month at that level, yeah, and you experience a difference, and let's say you do another month, and let's say you're like, okay, I've invested a lot of money now. You could almost start to think, okay, well, maybe I've rebuilt my reserves of it in my system. And if you can't sustain it month to month to month because you don't own the company and make the stuff yourself, you might say, okay, you could take a break and then go at it again when you start to feel things starting to slip again. Like if you're a healthy person just looking for that extra edge, I think it's worth it to do at least a couple of rounds a year.
Yeah. And really, it's really about the finances, to be honest with you.
It's what it comes down to.
If you can afford this stuff, take it every day. Because your brain starts losing volume around age 30, around 40, 50-ish. You start losing brain volume a little bit each year. And so
shrinkage.
Yeah. And so it really is that situation. It's such amazing brain food and cellular food that is just not available in our food supply at all. But yeah, so if you want to have fun and try things here and there, obviously all the things that we normally do, like maintaining skeletal muscle mass, with just time restricted eating, those will help your body, stimulate your body to make plasmalogens and maintain those plasmalogen levels. But if you
Okay.
want to do a boost every now and then,
Just take it for real.
yeah,
On the egg yolk side, because you mentioned the animal-based
yeah.
phosphatidylcholine, which is really it's the one that's going to target the brain. It's the thing that's going to get to the brain. And you have a product that's an egg yolk based
Yeah, so exactly.
phosphatidylcholine. But can eating runny egg yolks be helpful as well in
Well,
that
eggs are
area?
amazingly good food. What the egg yolk oil product that we have, like it's plasmalogens and egg yolk extract and some other lipid mediator um, supplements inside there, is that it's concentrated. Okay, like when you eat an egg, it still goes through your digestive tract because it's going to have proteins and everything else in there. When you take the Prodrome PC Plus, like the Neuro PC or the Glia PC, and you take it on the fasting, so we always recommend you take these things fasting. It's going to go right in your it's going to go right into your chylomicrons, and it hits you like a hammer. It's really powerful nutrition, and it goes right to your brain and your muscles. Because when you eat eggs, which I'm a big fan of, everyone should be eating eggs, is that your digestion is slowed. Kind of trickles through your digestion process. When you take it as a pure supplement, it hits you.
It hits you.
And the other big thing with the Prodrome Neuro PC, why it's such amazingly powerful, is that since the omega-3 plasmalogens are in there at the same time as the animal-based phosphatidylcholine, when it passes through the gut lumen, it reorganizes, and so it actually delivers DHA phosphatidylcholine to the human body directly. Because see, phosphatidylcholine, when you take phosphatidylcholine, you don't actually absorb it in your gut. What gets absorbed is called lysophosphatidylcholine. Okay, the SN2 condition is removed, and then it gets reattached on the other side of the lumen wall.
Interesting.
And so, since we mix it with our omega-3 neuro, okay, which has a huge concentration of DHA, extra DHA, right? It's got twice as much DHA as the plasmalogen backbone. Then when it passes through, it's designed to one molecule of DHA comes off in the gut, and one stays attached as it goes through, and then it gets converted to a phospholipid. That extra DHA gets actually attached to the phosphatidylcholine. So you actually deliver omega-3 PC directly, and it's pretty powerful stuff. Yeah, so it's all of our patients have noticed big differences when they switch to the Neuro PC from the just Neuro. So we're just getting better and better each time we go. As we go.
I'm feeling like it's time for a tune-up. It's been a while.
Yes.
I'm going to have to place an order. Sure. I mean, you were out of stock for quite a while, so the good news
Neuro's
is
coming back in,
that's
and
over.
then obviously we're launching a new practitioner program, the Elite Practitioner Program, because we're just getting so big in these spaces, and especially these larger neurological disorders like ALS, MS. Like we need help. We can't service everybody at this point in time. So we need more training.
Well, you've got such a good base of practitioners who've been with you now for a couple of years. I would think the Elite is going to rise up primarily out of that group.
Do more training, especially with the new, more advanced blood testing. Like our Prodrome Scan 2.0 is coming out. It has another list of biomarkers on there for practitioners, and so learning the biochemical interpretations has been a bit of a learning curve for most of our doctors. And so,
listen, I can tell you guys that trying to interpret one of these tests is not, it's just, this is like 5.0 stuff. This is not you. I mean, it was really incredible listening to you going through people's tests. And the one thing I will tell everybody who's listening, literally pretty much, I don't think there's a single person you didn't tell and take creatine.
Exactly. Yeah, creatine.
Exactly. There were 24 people who did this brain reset, and every one of them was told, take creatine.
It's a big deal. Yeah.
If you take nothing else, take creatine. So it was, we all remember it. Everybody, whenever we talk about, are you taking your creatine? Yes. I need egg yolks. Okay. Well, thank you. This is a great update. I mean, look, the work that you're doing is absolutely spectacular, and you and your team of people and the practitioners that are working with you are moving the needle on things that people believe can't be moved on. And
Yeah, that's a big deal.
that's spectacular.
And we that's actually the biggest challenge right now is changing that mindset
Yeah.
and reaching critical mass of this is not um, anecdotal anymore. Like this is
Yeah. No, this is repeated.
very reproducible. Yeah.
Yeah. And even, and the other one is we've been talking about the brain, the nervous system, all those things, but we've barely touched on the heart. And, in cardiovascular disease or in cardiac failure or congestive heart disease, whatever the case may be, I would imagine, again, without recording another episode now, but again, I would imagine that bringing plasmalogens these plasmalogen precursors onto the scene moves the needle again in a different way.
Yeah, we can lower C-reactive protein overnight. Like you take a high dose.
Wow.
So we have kids, Dr. Keller gave a presentation on all of her kids with myocarditis issues, and she had C-reactive proteins from 20s and going down to 1 in a few weeks. Like we can neutralize C-reactive protein levels and restore cardiac function quite reproducibly. So it's your body's connected, right? And that's why restoring health it does do it all in a sense, because all of your cells, even though they have slightly different jobs to do, their cellular biochemistry is the same. All your cells have a mitochondria. All your cells have membranes. All your cells have peroxisomes. All your cells have these core operating requirements. They just then use them to do their job, right?
Yeah.
And they're already designed to do their job. And so we don't need to recreate a heart cell. Okay, we just need to let the heart cell be a heart cell. Okay.
Yeah.
And just make sure we give it what it needs to do its job, and it'll do its job. It won't just say, oh, I'm going to stop being a heart cell, I'm going to be a neuron. No, it's going to do it's just going to still do its job. And
it's heart job.
Yeah, exactly.
Yeah.
Yeah. And I think,
but you're restoring the body's ability to repair itself is what you're doing. You're essentially restoring the body. And it's what you said earlier is we're born for those of us who are fortunate enough to be born healthy, we are born with a system that can repair on the fly.
Yes.
What you're doing here essentially is making sure that it just keeps going, that you can just, and then once you kind of figure that out, it's actually simpler than people might think.
Correct. And your body can really detoxify itself as well. That's the other big issue. Like we really we've moved away from all this detox because your body has a bunch of natural detox mechanisms. And so if it's healthy, and we've done this on our animal studies, where we treat animals with nasty chemicals like cuperzone that causes demyelination, MPTP that causes specific dopaminergic degeneration. Like that's going to be worse than any kind of neurotoxicity, and it's going to be worse than any mold toxicity you'll ever experience, right? And so if we provide cellular capacity for animals, those toxins have no effect. The body's actually able to maintain the myelination. The dopaminergic systems maintain function in the presence of the toxin. So, so we don't have to. So I think health is very powerful. Health is more powerful than the toxins in our world. Clearly, don't expose yourself to unnecessary stuff. Like, I'm not saying that, right? And if you can remove toxins, obviously do that and minimize it. But the problem with detox is that there's no such thing as a detox that's 100% clean, right? It's going to take good stuff out with it. And so, and trying to balance it is something, you want to be careful with. And of course, I tell everyone, if it's working for you, keep doing it. Like,
Yeah, no. And I mean, you're talking about the chelations and things that are just so rough. I think the best detoxes that are out there are not detoxes. They're basically systems that try to optimize the body's systems of detoxification. Like what we're just trying, again, it's, I think that it's the height of arrogance to think that we can do for the body what the body knows how to do, because we don't actually really know a lot about how it does what it does. Right. So if we can, take a page out of your book and anybody else's book and say, what can we do to get ourselves out of the way and let the body do what it can do? Yeah. I think that's where the magic really starts to happen. So, which you're seeing a lot of magic. So we're going to have to get you a wizard hat at some point.
Well, no, it's really rewarding to to be able to go from research to the practical application, and the opportunity to work with so many amazing doctors and practitioners around the world it's really quite a privilege on my part. So,
Wow.
So.
Well, Dayan, thank you so much for all that you do. Thank you for making the time to be here today. So people, actually, why don't you one more time tell people where they can access the different resources if they're a physician and they are interested in training with you, or if they're, I don't know, whatever, anything else.
Prodrome.com, that's for the retail sales are, like for practitioners to get accounts to have access to our products in their practice, or any individual who wants our products. Prodrome.com. All the education, research, and if you want to find out all the stuff that we're doing outside of that, go to drgoodenowe.com. That's where you'll find the Restorative Health Center. Like if you have someone with ALS or MS, and you're interested in that kind of advanced programming, that information is at drgoodenowe.com.
And if you're looking to live a really long time and you want to tap into the longevity work, you might have to emigrate to that place called Moose Jaw, Saskatchewan.
There's still a few homes available, I hear. So.
There's a couple of plots left, not many. Thank you so much. It's been a pleasure.
Thanks.